Sorry, Gary. What do you do? Not hitting on all cylinders today. Okay, now we're starting. Okay, in progress. All right, so we looked at this the other day, right? We looked at these three examples. This is from, I can't remember if it was Friday or Thursday. I think it was Friday. So we said that we can review. We can solve problems like this because we can point to a single x. So all we have to do is isolate x. Got a lot of practice with that, right? We can solve a problem like this where we can't isolate x, but we can factor it. Magic numbers work. I can find magic numbers that multiply to negative 22 and add to negative 9. If it's in standard form, then when I factor it, I know that the product equals 0 only when each factor equals 0. So I can use the zero product property to find the solutions, right? Okay, the one that we couldn't do anything with was a guy like this. There's not a single x that I can point to, so I can't isolate x. And unfortunately, this time the magic numbers don't exist. There aren't numbers that multiply to 4 and add to 8. Okay, but
fake numbers.
We're coming up, and we can't even do it with our imaginary numbers this time. But we've got a strategy now. Does anybody want to hazard a guess? How could we utilize this trick that we've just been using to turn this example number 3 into an example like number 1?
2 squared root of 2.
What could I do? Remember what we just did. We said that if we started off with a x squared plus bx, so x squared was by itself, a was equal to 1, that we could come up with a certain number that we could add to x squared plus bx to create a perfect square trinomial that factored into a perfect square. All Chromebooks should be completely closed, please. Completely closed. Completely closed, gentlemen. Thank you. Okay, so we can start with just x squared plus bx, and we can build this perfect square. Now look what the result was. The result was, instead of a trinomial, if it's a perfect square trinomial, we can write it as a perfect square. Now that looks an awful lot like that, doesn't it? Right? Where I have a single x that's inside of a perfect square. Right? Okay, so what would I do? How about this? How about if I just take on the left side, if I get the left side of the equation into the form x squared plus bx. And on the right side, I'm just going to have some number. I'm just going to push everything else onto the right side because I got to get the left side to match that template if I'm going to complete the square. So what does that look like for this problem then?
X squared plus 8x.
Okay, so on the left side, I'm going to start with just a plain old x squared plus 8x. On the right side, I'd end up with what? Negative 4. Good. Okay, so now think about this. This is where we started with all those examples you just did, right? We said that we ought to be able to figure out how I could make this left side look like a perfect square, right? By just filling in these blanks. Got to fill in that square first. And then once I know what that square is, I know what goes in that square, right? Okay, so based on the value of b only, if b is 8, what is my perfect square factor going to be? 16. It's going to be a 4, isn't it? It's going to be half of 8. So step 1 is we're going to divide 8 by 2 to give us a 4 there, right? So we already know that on the left side of our equation, we're going to get a single x inside that factor. There's going to be my only x, right? All that I have left to do is figure out what we end up with on the other side. Now, these two steps are linked together, though. In order to get a 4 there, what number do I have to include in my trinomial up here?
16.
It has to be a 16, right? So if that's a 16, but this is an equation, I can't just add 16 to one side only. What do I have to do to the other side? Add 16. Good. Okay, and so Now, what do I end up with on the other side? I had a -4 to start with, but I had to add 16 to both sides to create my perfect square. So what do I end up with over here? 12. Well, that's what I'm looking for, isn't it? Right? That's the kind of equation I'm looking for. That's an easy one. That's a two-stepper. What are the two steps in order to isolate x?
2 out of 8 by 2.
No, so let me rewrite that. It looks kind of messy. So really, where we are right now, this is simple. Where we are right now, we've just got x plus 4 quantity squared equals 12, right? So what are the two things? Got a square root first, good, and then subtract 4. Exactly, right? So all we got to do here, this is no big deal. All we've got to do here
You got the wrong one.
What is going on with this thing? Something is really goofy.
Click off of it.
Ask
so that
Peter
bar-
answers.
No.
Peter's getting his revenge, I think. Oh, here we go.
Yet.
What the heck? What's this stuff?
Okay, so once we get here, this is easy, right? You just told me I'm going to square root both sides. So the square root cancels the square. Anytime I square root both sides, what do I automatically have to include?
Plus or
minus.
Plus or minus, good. And what is my 12, square root of 12 simplified to?
2 radical 3.
Yeah, I'm going to get a couple of 2's and a single 3, right? So I'm going to get 2 radical 3. Then I'm going to subtract 4 from both sides. And so I get x equals -4 plus 4 minus 2 radical 3. I'm done. How easy is that, right?
Pretty easy.
So that's our trick, right? We can always just complete the square on the left side to create a perfect square trinomial, right? Let's try another one of those. Okay, what about something like that? Okay, now let's start to think strategically. We're getting to a point in the class now where get in there. We're getting to a point in the class where we're going to start being confronted with harder quadratic equations, and we want to be smart about this. We want to take the path of least resistance. So you always want to try to do it an easy way, but if that fails, we'll just move on down the line, right? So our first option, can we isolate x? No, we got 2 x's there. We can't isolate x. So then the next possibility is factoring. Well, in order to see if we can factor, we got to put it in standard form, which means we're setting it equal to what?
0.
0, good. So how do I do that?
Add 1.
Add 1 to both sides, and so we get it into standard form. So I get x squared minus 3x minus 8 equals 0. Are there magic numbers that work here?
No.
They're not. So that's not an option for us. So we got to go to plan C. Plan C for us now is completing the square. So what's that amount to? Remember, to complete the square, I've got to get it into the form x squared plus bx on the left side.
Add 8.
So I just have to add 8 is all, right? I got to get rid of the constant term. I need a plain x squared by itself, and then an x term, and that's it, right? So we'll add 8 to both sides. And that gives us x squared minus 3x equals 8. Okay? So you can already tell me when we get down to this line down here, let me give myself a little more space in there. You can already tell me what my perfect square is going to be. What is it? So it's going to be negative 1.5 as a decimal it would be, right? I'm going to take half of b, so whatever's in there, step 1, we're going to divide it by 2, right? So I end up with minus 3 halves as a fraction.
Then you square root.
Okay, not square root, opposite of square rooting. Square. So I'm gonna take what's in here now, and I gotta figure out what goes on both sides of my equation, right? I gotta add the right number here to make this happen, which means step 2 is -3/2 squared is what?
5.
What's that gonna be, null? If I square a fraction, I just square the top and square the bottom. What is it? 9/4. 3 squared over 2 squared. So I'm gonna add 9/4 to both sides, right? That's step 2. Okay? Make sense? And then all I've got to do now for step 3 is figure out what goes there, right? Got to add up the numbers on the right side. So 8 plus 9/4. These are fractions, right? I'm going to treat the 8 as 8/1. How do I always have to add
Be
fractions?
11.
You gotta make sure the
You have
cross
to make them the same.
What make
Cross
what the
cancel.
same?
denominators.
Denominators, common denominator. So I'm gonna already have a 4 over here, so I'll multiply top and bottom by 4, and that's gonna give me on this side,
41/4.
good, I get 32/4 plus 9/4 is what now? 32 plus
40,
9 is
41/4.
There we go, 41/4. Right? Now all I've gotta do is same steps as before. I get a square root and then add that term to both sides, right? Yeah, it's no big deal. So if we square root to cancel the squared, we get x minus 3/2 equals, what do I always have to put?
Plus minus.
Plus or minus? Okay, and the square root of 41/4. Now all that is the square root of 41 over the square root of 4. So what's the square root of 4?
2.
2. So the bottom, that worked out great. The bottom is 2. Square root of 41, I think 41 is
6
prime.
ninths.
Prime, yeah. So we're not going to, the top, we're just stuck with radical 41.
Yes.
So then the last step is what? Add 3/2. So we get x equals 3/2 plus or minus the square root of 41/2. That's our answer. That's an exact answer, okay? All right, one more. Woo! Okay, what about this guy?
Minus 2.
Okay, this is about the hardest one I can give you. You can do this, you can do any of them.
Half of 30.
Okay,
square
first
root
of all,
30.
okay, I got a question. First of all, are there magic numbers in this case?
Nope.
For bottoms up? There aren't. I'd have to find numbers that multiply to AC and add to B, and there aren't going to be any. But I would argue that maybe, to me personally, I think completing the square is easier than bottoms up. You might feel, I don't know, I mean, it's probably 50-50 on that, but I would almost rather just complete the square than even mess around with bottoms up. Okay, but this time, think about the steps here, because the starting place for our bottoms up is, remember, we have to get this in the form x squared plus bx equals a number, right? So I gotta do two things. What's one of them? Gotta subtract 10. I gotta get rid of the constant. So one thing I gotta do is subtract 10. Okay, and that's gonna give me 3x squared minus 30x equals negative 10. Now what?
Divide by 3.
Okay, I gotta divide by 3. Okay, now, because I gotta get rid of the 3 in front of the x squared. If I divide the whole left side by 3, does everybody see that that's exactly equivalent to dividing each term separately by 3? So in other words, I could write this over one common denominator, but think what a common denominator means. It just means a shared denominator, right? So it'd be more convenient for me instead to probably just write it like this. Just to divide each term by 3, right? And then what happens? 3's cancel, so there's my x squared like I want, and 30 over 3 reduces to? Good, negative 10x, and then over here we've got our negative 10/3. Okay, so what's going to be our perfect square then?
X minus 5.
X minus 5. Everybody agree? We take half of negative 10 gives us negative 5, so there's step 1. What's step 2?
Square root.
Well, square root.
You square it.
Square. So I'm going to take the minus 5 and square it. So that's going to give me 25. Whoops. 25 on both
25.
sides. Everybody agree? Okay. And then step 3 is going to be, I'm just going to add those up to get one number. So let's give ourselves a little more room than that.
75 thirds, right?
Yep.
So 65 thirds.
So we need a common denominator of 3. Good, so we'll multiply top and bottom by 3.
65 thirds.
Everybody agree? So that's going to give us, what's that going to be? Negative 10 thirds plus 75 thirds. So 65 thirds, okay? Okay, everybody with me? Okay, and now
You square
we,
root.
we completed the square. Now all we got to do is isolate x.
Square
So
root.
square root, good. So that's going to give us
Then you
plus
add
or
that.
minus square root of 65 thirds. So we're going to square root both sides, right? To get rid of the squared. Okay, so what are we going to do with this? Now we got to go back and think about our stuff that we reviewed at the start of the year a little bit. So everybody focus really hard on this. So this is going to look like if I take the square root of a quotient like this. First of all, if 65 thirds reduced, I would do that. I want to make this fraction as small as possible, but unfortunately they don't, right? So if I'm stuck with taking the square root of a fraction, I'll just split it up into the square root of the top over the square root of the bottom. But what happens when we end up with the square root stuck in the bottom?
Bad thing.
Well, no, but we can't leave it there, right? We can't have a stranded radical in the denominator. We have to undo that radical in the denominator. What do we do? We're going to multiply both the top and the bottom by whatever the stranded radical is in the bottom. Remember that? So we'll multiply the top by the square root of 3 and the bottom by the square root of 3 because what is the square root of 3 times itself, or the square root of 3 squared? Square root of 9, which is 3. Yeah. I'm squaring a square root when I multiply it by itself, so it cancels out the radical, doesn't it? So that just gives me a 3 on the
Square root of
bottom.
65 over 3, right?
Yeah, and on the top I'm going to get 3 times 65, which is 195. And then we'd have to see, does 195, can we simplify that? So we'll go up and try. Well, we know 195 factors into 65 and 3. And 65 is, what is that? 5 and 13. So 13, 5, and 3, we got no couples. So does anything go out?
Nope.
It all stays in. So then we just end up with plus or minus the square root of 195 over 3. And what's our last step?
Add 5.
Add 5. And we're done.
X
So
equals
X,
5 plus minus.
there you go, plus or minus radical 195 over 3. There's our two answers. How would we input those in Moodle?
With a comma.
Plus,
the one
comma, minus, right? Okay, make sense?
Kinda.
All right, that's a lot of stuff for one short Monday. But I'll put up some assignments. You guys can just work on those over the next couple days.
You can't just do it plus or minus.
It just won't take it. Just the way, it's a computer algebra system and it only recognizes like a list of answers as multiple answers. So I wish you could, but you just can't. I don't think you can do it on any computer algebra system that I've seen.